Hello, let's look at concurrency in Rust. We won't be looking at Tokyo. We'll be looking mainly at MPSC, multi-producer, single consumer channels. Goal of this video is to build upon what I've learned in the past. So this won't be kind of an intro. It'll be just talking about the new things that I'm learning. One of which is dealing with timeouts. And the other thing is working with a function, putting your sender into a function. So just a quick recap. So channels are designed for communication between multiple producers in one consumer. They allow data to be sent from several threads to one receiving thread. Great. So this is the Rust standard documentation. This is the standard sync MPSC channel, because you can also get a Tokyo one with a similar name. So what it does is it creates a new asynchronous channel, returning the sender receiver halves. All data sent on the sender will become available on the receiver in the same order as it was sent. Okay. So this is a very small example. We've got let TX and RX tuple. So we're destructuring the MPSC channel. The TX, so we've got one transmitter and we've got one receiver. So the one transmitter is sending 4 things. So after sending, the sender will be dropped, which will close the channel. Dropping the sender causes the channel to close, but you can still receive anything that's already been sent. So 4 received in RX, where RX is the receiver. When you run it, you get hello world from sender, and it's all in order. It's all in the sequence in which it was sent. So let's use multiple TXs, multiple transmitters. So we'll clone the transmitter within a for loop, and then we'll spawn a new thread, and each new thread will use the consecutive cloned transmitters. So we're going from 0 up to 5, so that's 0, 1, 2, 3, 4. So we'll have 5 threads as well as the main thread. So we'll have 5 threads and we'll have 5 transmitters. And then at the end, we're just using the underscore. So we're just iterating from 0 to 5, and we're just going to collect or receive all of what we sent. And you can see we're just doing result I times I, just to calculate the square. So the key part here really is that it is doing a clone, TX clone. You're cloning the transmitter. And then at the end, we've just got one, we're doing a send inside each of the threads. And then at the end, you've just got one receive. So when you run this code, you could get different results, or you almost certainly will get different results. And that's because we've got different threads. So when you've got multiple threads, they arrive back in any order. So one other idea I had was, how do we set timeouts for message reception to prevent the receiver from blocking indefinitely? And you can use recv underscore timeout. So where you would previously in this code have put rx.receive or recv, you can replace it with recv underscore timeout. I'm using match here, and many of the basic examples will show unwrap, and you can use that, but obviously it's not recommended for production code. It doesn't deal with panic and so on. So here we're handling OK and error. Note we're using a function here. So again, in the most basic examples, you won't have a function, you'll just have a thread. You'll have threads spawn, and then you'll just dump all the code into there. Whereas here, we're actually writing a function which we pass in. So let's look at some code. Okay, so this is the code that we started to look at just then. So use standard sync MPSC. Remember, there is a Tokyo version as well. Use standard thread. use standard time duration. We're just using that so that we can fake a delay so that we can test our timeout. So we're going to have two functions. The first function is the sender thread function. Second one is the receiver thread function. And then we have main. So back up to the sender thread. What we do is we pass in the transmitter, and then we're going to sleep for 3 seconds. The reason for that is that we're going to test the timeout. So then we'll attempt to send. So the tx.send will send number 42. Any successful result will print message sent successfully, otherwise we'll display the error. The receiver thread, we're going to set a timeout. Notice here the timeout here is 2 seconds. The delay on the sender is 3 seconds. So to send is going to take 3 seconds, and our timeout is 2 seconds. So this should demonstrate the error. And we're using receive timeout as per what we just looked at, rather than just RECV. So it would work. If you didn't want to use the timeout, you could uncomment that line, and you could do that. Run the code. Sent successfully. Now if we use the timeout, we'll get an error because the timeout, error message. Because the timeout was less than the duration of the send. Okay, so down in main, all that happened was we deconstructed. Let me just turn off the hints, the type hints. So we deconstructed the MPSC channel. You'll always do that. You'll always see that whenever you're using a channel. And then we had a function, which was the sender thread, and we just passed in the dx, which was the 42. You always have to move it to take ownership of it inside the thread. So that's the sender. And then we spawned sender, we spawned the receiver, and then we joined them at the end. The reason we join is because if main finished first, then this would not complete. So it's always, I think it's best practice to use that. So with the timeout, we'll leave the timeout here, but if we make the sleep, we'll make that 1. Oh, sorry, 1. And this should complete successfully because it's going to sleep for 1 second, but the timeout is actually 2 seconds. There we go, message sent successfully, received message 42. So this is really just the beginning of looking at MPSC. As I say, I'll mention in a second about Tim Clicks because I got the inspiration for this video from that. So yeah, let's go back to that. Okay, so just to round up, the biggest benefit of using a multi-producer single consumer channel is safe and efficient communication between multiple threads, and it prevents data races. As I said earlier, we have got Tokyo Sync MPSC channel also, and that's also in the documentation. As of May 2024, we're on Tokyo 1.37. So this was Tim Click's video where he make a port scanner in Rust with Tokyo and learn async Rust. Although it was mainly focusing on the async side of things, he did use channels. I think he created 10 channels. So you can specify the number of channels you want as well. Again, I've read the documentation and it says it's arbitrary, the number you choose for the number of channels. But I think 10 is probably quite a good number to specify if you are doing so. If you like these videos, please consider, you can zap me some sats if you know how to do that with your Lightning wallet. Use that QR code. And yeah, subscribe, thumbs up and all that stuff. If you've got any questions or comments, feel free. I'm still learning about MPSC, about channels. So yeah, I'll try and progress from this one to something a little bit more real world rather than just sending the number 42. But one idea I had was actually to, where Tim was using it for a port scanner, I was actually thinking about using a channel or multiple channels to make multiple SSH connections. If you've seen my GUI SSH videos with Iced, I was attempting to, or I was successfully connecting to one SSH host. But imagine you had a large network and you wanted to connect to lots of switches or routers or firewalls, then you could look to use channels. So that's one idea I've got. May or may not do that, depending on the level of interest and if I move on to other things. But yeah, I'm trying to just go back over a few things because it's been a 2 or 3 months now since I looked at Arc, since I looked at concurrency in general. So yeah, thanks for watching. I'll be back soon.